You know, for the better part of a century, our entire digital world has been built on a really simple, really elegant idea. But that idea, well, it's hitting a wall, a hard one. And what comes next could literally change everything.
Just think about it for a second. That device in your hands or sitting on your desk right now, your phone, your laptop, whatever it is. It's crunching billions of calculations every single second, using just two simple symbols, a 0 and a 1. That's it. That's binary. It's the absolute foundation of our modern world.
But what happens when that elegant, simple system just isn't enough anymore? What happens when the engine that powered the 20th century starts to run out of steam? What happens when 2 is no longer the magic number?
And this isn't some far-off, hypothetical question. We are right there, right at the very edge of what binary computing can physically do. The party that's been going on for decades is kind of winding down, and we desperately need to figure out what comes next.
Ever since World War II, the name of the game has been making things smaller. We've all heard of Moore's Law, right? This idea that we can just keep cramming more and more transistors onto a chip year after year. Well, that incredible shrinking act is finally bumping up against the hard laws of physics. And that brings us to what people in the industry are calling the 3 big crises. First, transistor stagnation. We're getting them so small that electrons start to misbehave, doing weird quantum stuff that makes them unreliable. Second, the power density crisis. Our chips are so jam-packed they generate a scary amount of heat, putting the brakes on data center growth. And third, the energy wall. This one's a monster. The power that AI demands is doubling every 6 months. That is just completely and totally unsustainable.
So where do we go from here? Well, the solution might not be some brand new idea, but actually a really old one whose time is finally come. Instead of just on and off, what if we added a third option in the middle? Welcome to the world of ternary computing. The basic idea here is actually beautiful in its simplicity. So binary has 2 states, right? 0 and 1. We call that unit a bit. Ternary just adds a third state, -1, 0, and +1, and we call that unit a trit. It's just a more expressive, a much more efficient language for computers to speak.
So let's dig into that a little. A single trit holds about 1.58 times the information of a bit. Now I know, that number might not sound like a huge leap, but trust me, it compounds in an incredible way. It means you can say the same thing with far fewer trits than bits, and if you have less stuff to move around, you save a ton of time and, crucially, a ton of energy.
And hey, this is not just a theory. Get this. Way back in 1958, Soviet engineers actually built a ternary computer called the Setun. And the results? They were absolutely stunning. It used way fewer parts and was drastically cheaper than the giant binary mainframes of its day.
So, if it was so great, why isn't your phone a ternary device right now? Well, the Setun was this brilliant piece of hardware, surrounded by a world that only spoke binary. It failed because there was no software, no tools, no ecosystem to support it. And that is a huge lesson for today.
Okay, so if it fizzled out back then, what's different now? Why are we even talking about this? Because today, the game has completely changed. We finally have the materials science and the manufacturing know-how to make this 60-year-old dream a reality.
Let's just run through some of the recent breakthroughs, because they are wild. A patented design from Huawei for a tiny 7-nanometer ternary transistor. It uses 40% fewer physical components to do the same job. That is a massive leap in simplicity right out of the gate. But that's not all. That same design also gets a 20% boost in raw speed. So not only is it simpler, it's also a whole lot faster.
And here is the real knockout punch. 60% lower power consumption. Remember that scary, unsustainable energy wall we talked about? Well, this is how you start knocking it down.
So what's the magic sauce here? It all comes down to amazing new materials. Things like graphene nanoribbons and carbon nanotube transistors. These materials can reliably hold 3 distinct electrical states, something that was basically a pipe dream with old-school silicon.
So, we've got the tech. What does this actually mean for us in the real world? Well, the payoffs are just staggering, especially when you look at the most demanding stuff we do, like artificial intelligence.
I mean, look at this. When you build AI chips with this new ternary tech, the results just speak for themselves. The chip area, the physical footprint, shrinks by 45%. The amount of switching, that's the action that burns power, drops by 35%. And the bottom line? A 30% total energy reduction to do the exact same work. It's smaller, it's cooler, and it's way more efficient.
And this right here is a perfect example of why it's so much better. In binary, if you want to compare two numbers, is A bigger than B, or smaller, or are they equal? It's a whole process, takes multiple steps. But in ternary, you can do it with one gate in one go. The output, -1, 0, or +1, is the answer. It's not just faster, it's fundamentally smarter logic.
Okay, I know what you're thinking. This sounds way too good to be true. So, what's the catch? Well, the catch is that revolutions are incredibly hard, and the roadblocks to a ternary future are, frankly, enormous.
I mean, just try to wrap your head around this. For over half a century, every single piece of our digital infrastructure, from the software that compiles code to the massive cooling systems and data centers, it's all been designed, built, and optimized for a two-state, binary world. That's an unbelievable amount of inertia.
And the challenges are very real. Physically, it's just harder to reliably tell 3 voltage levels apart than 2, which creates issues with noise. Then there's the software. We're talking about rewriting everything from the operating system up. And finally, you have the economics. Convincing someone to retool a multi-billion-dollar factory for a whole new way of doing things, that is a huge risk.
So a complete total replacement isn't going to happen overnight. The most likely path forward isn't an either-or situation. It's much more clever than that. The future is probably hybrid.
And this is the really smart part. You don't have to throw everything out and start over. The idea is to use binary for what it's still great at, running all our existing software and managing the basic system tasks, but for the really, really hard stuff, the super intense calculations for AI or cryptography, you offload that to a specialized hyper-efficient ternary coprocessor. You literally get the best of both worlds.
For decades, progress always meant one thing: making things smaller. But we're pretty much at the end of that road. The next great leap forward in computing probably won't come from shrinking things down anymore. It's going to come from a fundamental shift in how we think about information itself, from thinking in 2s to thinking in 3s. The only question is, are we ready to make that leap?